Hi guys. Today we're going to work on some worked examples using exponents. So this is a really nice example of just keeping track of all the different exponent rules. Now you're going to notice this is posted in Canvas for you so you can print off your own copy. Um, I'm just going to talk you through first all of these, and then we're going to solve a problem showing how we would actually use this and solve problems like this. So the first thing is if you are adding and subtracting monomials, they have to have like terms. So if you have x squared y and x squared y, then you can actually add or subtract them. You guys are used to doing this, okay? So that is the number one rule for combining like terms. Now, the next thing we're going to look at is the product rule. If you have the same base here and different exponents, you are going to add the exponents together. The key thing is that you have to have the same base. Remember, we have the base and the power. So our base here is x, our power is a, base is x, power is b. We can add the powers together if they have the same base, just like this. H squared plus h to the sixth would give you h to the eighth. Okay? Same thing. They have this a squared. Okay. Now you're noticing, hey, Mrs. Sagersir, up here we had to have like terms. That's only for adding or subtracting. Okay. Once we get down here and we're multiplying, you are going to look at all of the a's. We have a squared and we have a to the third. So they have the same base. Even though there's other things in there, you are going to end up with a to the fifth. B, it would be to the first power here, b to the first power, so we're going to have b squared. And then you multiply all your constants together, and that's how we can use the product rule to simplify exponents. Now, with the powers rule, if we have x to the a, and then there's parentheses, and the whole thing is raised to the b power, you are going to multiply the powers together. So that's different than this. That's just multiplied straight up. Here we have the whole thing in parentheses raised to the b power. So you're going to multiply those. So that's how we get x to the sixth. And here we're going to multiply everything inside the parentheses by itself. So it's going to be negative 2m to the fifth times negative 2m to the fifth, right? So we would say 5 times 2 gives us m to the 10th. Negative 2 times negative 2 would give us 4. So we have m to the 10th times m to the third. Then we're going to add those up just like we did up here and get m to the 13th. Okay. Now the next one we have is the quotient rule. We have the same base, but we have different powers. So you're going to end up subtracting the powers. So you're going to have whatever the power is on the numerator minus whatever the power is on the denominator. That's only if you have the same base. So here our base is x, our base is x. So our exponent is 5, here our exponent would be 1. 5 minus 1 is 4, so we're going to get x to the fourth. And then all the constants out front, we're just going to simplify them as much as we can. Okay, so the key thing to remember is be super laser focused clear on what your base is and what your exponents are. And that's going to tell you how you're going to deal with it. So the next one we're going to deal with is negative exponents. And we're going to work a couple examples of these because this is a little tricky, but you guys are going to be able to get this. All you need to know is that if there is a negative exponent, it means you take that whole thing, put it on the denominator, and give the numerator, let the numerator be 1, okay? So same thing, look at this. We have x to the negative 2 power. You are just going to put that on the bottom. Everything else stays on the top, okay? So anytime, and then here, if you have a smaller exponent on top than on the bottom, you would say 2 minus 5 would be negative 3. So if you were to write it with negative exponents, you could write it as, let's see, 4 divided by 8. So it'd be like 1 half k to the negative third. But if you are asked to write it with only positive exponents, 1 over 2k to the third is the same as 1 half k to the negative 3, or negative third power, okay? So we'll work through some more examples of these negative exponents. And this one's easy. This is my favorite. Anything raised to the 0 power is just 1. So if you had 4 to the 0 power, it's 1. If you have x to the 0 power, it's 1. So 1 times 7 is 7. Now here we have 4 times 2, right? Because we're looking at our power rule, and 8 over 8, right? We'd have w to the 8th over w to the 8th, and that simplifies to just 1. Or another way to think of it is if you had 8 minus 8, if we were to use the quotient rule, you'd have w to the 0 power. Anything to the 0 power is 1. So now let's work some. So in the first part of your homework, you're going to be solving things with 0 exponents. Anything to the 0 power is always 1, right? Another one you might solve if you have a negative number raised to, let's say, to the 5th power. You know you are going to have an odd number of negatives, so your answer is going to be negative. So always remember that if you have a negative number raised to an odd power, your answer is always going to be negative. But the example I want us to look at is negative 2 raised to the negative 5th power. So you're going to rewrite that as 1 over negative 2 to the 5th power, because that negative just tells us you need to flip it and put it on the bottom, okay? Now, negative 2 to the 5th power would be negative 2 times negative 2, and so on, 5 times, right? So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So we have 1 over 32, and we remember that the whole thing is going to be negative because we had an odd exponent acting on a negative number. Okay, here's another one with a negative exponent and 0 power. So let's just simplify the 0 power first because that's super easy because anything to the 0 power is just 1. So we still have 5 to the negative 1. Now all that's going to tell us anything to a negative power goes on the bottom. So we would have 1 over 5 to the first power. And that is just plain old 5. So our answer is 1/5. But we have to remember that we started with a negative here, so we can't just get rid of that. That goes there, and our answer would be a negative 1/5. Okay, this is a little bit more exciting one here. Guys, I want you to remember that you cannot do any of the quotient rules unless you have the same base. So here our base is negative 8 and our base is 3. So we have to simplify the top and then we're going to simplify the bottom, okay? So the first thing we are going to do is deal with the negative exponents. And since they are both negative here, we can actually just flip the whole thing upside down and we would have 3 to the 4th because that negative just tells us, hey, that needs to be on the numerator instead of the denominator. And then we have negative 8 squared. So now that's a lot easier because we're only dealing with positive exponents. So 3 to the 4th would be 3 times 3 times 3 times 3, or you could think of it as 9 times 9, right? So 9 times 9, and then negative 8 squared. Anytime you have a negative raised to an even power, you know it's going to be positive. So 8 times 8 would give us a positive 64. So if we simplify further, we have 81 over 64. And I don't think that's going to simplify down at all. Okay, the next part of your homework is asking you to simplify and write your answer only using positive exponent because negative exponents are just, you know, not the cleanest form to write our exponential functions in. So remember, we have PEMDAS, right? So we don't have any parentheses, but we are going to deal with exponents. So 10 to the 0 power is just going to be 1. R to the negative 11 means we're going to put it down here on the bottom. S is going to stay on the top. And 3 squared, we can go ahead and evaluate and say that is 9. So if we were to write that even simpler, we don't have to say 1 times S. We can just say S over 9R to the 11th. And all of our exponents are positive. We're not dealing with this nasty negative exponent. And we're done. Okay, again, our strategy is to write this all with positive exponents. So the first thing we're going to look is at the base and see if any of the bases are the same, and they are not. So What we're going to have to do, since every exponent is negative, is completely flip this over. So we're going to put p to the eighth on the bottom. You notice because it's on the bottom, it's a positive exponent, and then everything else on the bottom is going to go to the top. So 7 squared would be 49, and it would be q to the ninth. So you are going to work out any constants that are squared and make sure that all your exponents are positive. The next part we're going to look at is where the bases actually are the same. So here our base is -6, and our base here is -6. This is to the eighth power, this is to the fifth power. We are going to look at our sheet and we are going to say, hey, we can use the quotient rule. So we can take the power on the top minus the power on the bottom. So let's do that. So we would have -6, and then we'd subtract the powers. So if we simplify that, that would be -6 to the third power. And again, we're going to say it's a negative number raised to an odd power, so we know our answer is going to be negative. And that would be 36 times 6. But I'm going to sing a song for you guys, and this is going to be the end, okay? If you want to learn your cubes are like 1 times 1 times 1 equals 1. 2 times 2 times 2 equals 8. 3 times 3 times 3 equals 27. 4 times 4 times 4 equals, and I actually have a song for this. 1, 8, 27, 64, 125, 216, 343, 512, 729, 1000. And those are all your cubes. So if you know those, then you would know that, hey, this is going to be 200, negative 216. I promise I'll sing that in class. Don't laugh. Bye, you guys. Good luck and great luck solving and simplifying exponential expressions using the rules, exponent rules.